Welcome everybody to note video number 6. We are starting part 2 of unit 2, and today we're going to start talking about the atom. So part 2 of unit 2 is all about the periodic table, the elements, how the periodic table came to be, how our idea of atoms came to be, and how we actually use the periodic table to do things in chemistry. This is going to be a really short note video. It's only one page in the notes. And the topic of this particular video is specifically the atom and what makes it up. So every bit of matter in the universe, that means anything that has mass and takes up space, is made up of atoms. And atoms are made up of two regions. We have this inner region here, and then we have this outer region. The inner region are the tightly bound spheres in here, and then the outer region is this whole field that ends up showing in this picture as like different layers of really fast little blue stripes and dots. And then there's three particles that make up these two regions. Now, as you further advance into science, you're going to learn that there's a lot more going on here than just two regions and three particles. Each of these particles is made up of tinier particles, and those particles are made up of even tinier particles, and you're going to learn about quarks and leptons and neutrinos, but that probably won't be until you get to some advanced chemistry in college. For now, and for most of your high school, all you're going to need to know is there is an inner region, there's an outer region, and they are made up of things called protons, neutrons, and electrons. So let's explore those. The two regions in the nucleus, the inner region is called the nucleus, much like it is called in a cell. And this is the center part of the atom, and it contains most of the mass. When I say most of the mass, I mean like 99%, 99.9% of the mass of the atom is found in just that central spot. Around that central spot is the electron cloud. And this is where the electrons are found, and they're just zooming all over the place at nearly the speed of light. Electrons are the fastest bits of matter that there are. According to one of Einstein's theories, the theory of relativity, I believe, matter cannot go the speed of light, and electrons go really close to the speed of light, so they are the fastest moving bits of matter. So we got your two regions here again. So what are the three? How big is an atom? That's a good question. If an atom were zoomed in and we made an atom the size of PNC Park downtown, if you took an eraser from a pencil and put it on the pitcher's mound of PNC Park, that would be the size of the nucleus. So if the atom was this entire stadium, the nucleus, where 99.9% of its mass is found, it would be the size of an eraser on that pitcher's mound. The entire rest of the park would be where the electrons would be going, and they'd be zooming all over the place. They'd be going everywhere. We're going to learn in a few days that you tend to find electrons in certain areas more than you do others, but for the most part, they're just zooming around. They're going so fast that they're almost everywhere at once, but there are definitely regions that they prefer. One thing that kind of boggles people's minds sometimes if you think about that, if you think about the fact that most of the mass of an atom is the size of an eraser on a pitcher's mound in this big stadium, that means that the rest of the stadium, the rest of the atom, is pretty much empty space. So all matter is made from atoms, and atoms are mostly empty space. That means all mass is mostly made up of empty space. Something that's awkward to wrap your head around, but quite true. So the three particles, and this will sum up today's notes, and you're going to need to know about each of these. There is the neutron. The neutron was actually the most recently discovered particle in the atom, of these three anyway. It's found in the nucleus. It has no charge. That's why it's called a neutron, because it's neutral. And it's slightly bigger than a proton. So it is the biggest of the three particles. Also found in the nucleus is the proton. And proton has a positive charge. And we like to say that a proton has a mass of 1 AMU, and that means an atomic mass unit. Essentially, protons were like the first things that we discovered inside of an atom, so we base everything else on it, and it has become our standard unit of mass measurement. So it's the atomic mass unit. It's just the size of a proton. An electron, on the other hand, is found zooming around the nucleus in the electron cloud. It has a negative charge, and it's really super tiny. It would take 2,000 of them to have the same mass as a proton. So electrons are really, really small. And by most accounts, if you combine a neutron, or if you combine a proton and an electron together, well, you would be combining a negative and a positive. Those charges would cancel out, so you would have no charge, and you would end up with a mass slightly larger than a proton. In fact, just a teeny tiny amount bigger than a proton, and you would then have a neutron. So if you combine the proton and the electron together, kind of working your way towards a neutron. These are the three parts of an atom. Protons, neutrons are in the middle. Electrons are zooming around the outside. Neutrons are neutral, protons are positive, electrons are negative. We're going to learn a lot about a lot more of these things in the coming weeks. Some structural things to think about. Keep in mind that all the protons are in the nucleus. Well, protons are all positive charges, so what do positive charges want to do if they're close to each other? Remember, opposite charges attract and like charges repel. So you have a whole bunch of protons crammed into the nucleus, but they're all positive charges, so they all want to actually move away from each other. And it creates lots of kind of stress in that nucleus, and there's a few forces that kind of hold it together. There's one called strong force that happens when you actually get these two protons to touch, and it's the strongest force in the universe, and it's what holds these neutrons together, or I'm sorry, holds the nucleus together. The neutrons help because they add some like buffer in between some of the protons. And then when nuclei get too big, then the protons, there's so much positive force there repelling each other that they start to fly apart. We'll learn later what happens when you do that. The electrons are zooming around the nucleus. They have opposite charges than what's in the nucleus, so they're kind of attracted to the nucleus, but their great speed keeps them going around in the electron cloud. And as we're going to learn later, the electrons are what take part whenever two atoms bond together to form a molecule. The nucleus of two atoms never touch. So there's some precursors into what we're going to be talking about here over the next few weeks. For this booby trap, make sure you know the two regions. Make sure you know kind of how big an atom is and how big the relative sizes are, the three parts, how big they are in comparison to each other, and their charges. And we will have 9 questions on that. Thanks. Have a nice day.